The next topic is linear speed v. If we have an object going at uniform circular motion around the periphery of a circle, as we said in the previous YouTube, t is the period of time that it takes for the object to go around once, and omega is the angular frequency. And at any particular point, the velocity is tangent to the circle, as I've shown right here. So if I drew a radius vector from here to here, in fact, let me do that. If I drew a radius vector r, v would be perpendicular to the radius vector drawn out. And the velocity, or the speed, can be very easily understood as being the circumference of the circle divided by the period, because that in fact is the distance it goes per unit time. So circumference is 2 pi r of a circle divided by the period t, but we can separate that into two factors, 2 pi divided by t times r, and so that's going to be omega, that's what this is, times r, or writing it in the opposite order, r times omega. One important note here is this formula must have the omega has to be expressed in radians per unit time. And usually we'll do radians per second, but you could use some other unit of time as well. To take an example of this formula, let's say we had a large clock on a church that had a 1 meter minute hand. And I asked you what the linear speed of the tip of the minute hand was. Well, we could use the formula. V equals r times omega. 1 meter is the radius of the hand. We can put that in. And we can understand pretty easily that the minute hand has an angular speed of 1 rev per hour. However, we need to convert the revs to rads to use this formula properly. Omega has to be in rads per unit time, and I'm also going to convert hours to seconds. So I have two conversion factors here, the first one being 2 pi rads over revs. And so let me do the same thing I did on the last one. So this conversion factor will take revs out, and then the second one will take hours out, leaving us with meters per second. The radians disappear. You just see meters per second here. Radian is a dimensionless unit. When it's combined with other units, it disappears. And so that, if you do the calculation, and you should be doing the examples when I show you a YouTube like this, you should get 1.75 times 10 to the minus 3 meters per second, and so that would be the same thing as 1.75 millimeters per second.